What's going on, everybody? Ollie from flightcomp, and I'm back with another video. This one's going to be a little different. We're going to be talking about designing a V-tail for the Vertigo F5J. I have here in front of me a Vertigo boom. This is one of the prototype booms I got back when the Vertigo was in development, so the front's a little different, but the back was the same. And as you can see, we have the makings of a V-tail right here, so pretty exciting. Now, we're going to go over designing a V-tail in Solidworks. I've done all the design work myself. I've wanted to make a V-tail for the Vertigo for a long time, but GCM has been pretty busy with other projects. So they didn't really have the time to devote to designing these parts. So I talked to them a little bit, and basically we came to the agreement that I would do the design work, and those guys would machine some molds, and we could get some V-tails made. And as you can see right here, I have 3D printed some parts to do some test fitting. And with V-tails, there's several different theories on how to design a V-tail as far as projected areas and using the actual area of, let's say if you had an existing X-tail, some guys would say using a projected area of the X-tails, or other guys would say to use the complete area, the total area of the X-tails on the V-tail, actually, so basically making them very, very big. I'm not going to get into any of that because there's tons of discussions and debates on RC groups and other forums about designing V-tails. I don't really want to get into any of that. Needless to say, I went back and forth with GCM quite a bit about this design. We took a lot of time in kind of coming up with a design that we think will work really well with the Vertigo. And I'll just leave it at that, basically. So we're pretty confident in the design, or the numbers, you know, the area and the angles and things like that, and the airfoil. In this video, we'll just show you how things kind of come together in the 3D world or in SolidWorks, and how I went about designing all this stuff. So I'll give you a close-up of these 3D printed parts, and then we'll dive right into the SolidWorks. So here we go. Here is the makings of a V-tail. I can actually remove these parts from the boom. This is a 60mm section of our V-tails. Obviously I didn't want to print the whole thing because that would just be ridiculous. I have some metal rods and a little carbon pin in here to simulate the carbon joiner and alignment pin, and we have a control horn here, and you can see the hinge line right here. So basically these parts are almost identical. We are going to use offset joiners, so these joiners aren't, you know, identical as far as their placement from the leading edge. So that's pretty straightforward here. And then we have what I call the V-tail mount. So these parts are pretty much identical, except on this is a final version, and I've increased the size of the carbon joiners to 6mm, and I've increased the size of the alignment pins to 4mm. On this guy, I had it at 5mm on the main joiner and 3mm on the alignment pins, and kind of thinking that was too small. And I also have some cutouts here for the push rod exits, but we'll cut those in the final carbon parts so they don't have to be in this 3D molded part. And the push rods are going to basically exit outside of the fuse and hook up to the tails with ball links. So there's not going to be a cover over this, or like a cone. A lot of other models with V-tails have a cover that goes back here. I designed this to be as easy as possible to assemble at the field, basically just as easy as putting an X-tail together. So there you go. And this guy here, I've already started kind of sanding this, and what I'm going to do is actually prime and polish this and take a mold off this part, epoxy mold, just for prototyping purposes, I really want to lay up 1 or 2 carbon pieces and attach them to the booms and just see how everything works with the push rods and the ball links and the control horns and all that kind of stuff before we go into aluminum molds. The V-tails themselves will probably go straight into aluminum molds. We might mill plastic prototype molds first. I don't know. We're still kind of debating that. So there's my 3D printed prototype parts, and now let's take a look at the computer work. Alright, so we're in Solidworks. Here is my V-tail. This is basically the finished product. Only changes that might occur are to this control horn here. Still kind of thinking about what material to make this out of and whether it'll be installed while the part is being molded or after the fact. So that might change, but everything else is basically set. So kind of go over the workflow of things. The first thing I did was try to come up with a plan form, and like I said, we already had the area set, so I needed to come up with a plan form to sort of match what our projected area goals are. And to do that, I made a basic sketch here. You see the angle of our tails is going to be 95 degrees, so I've drawn a straight line here. So if this was kind of a straight down view, so I could create a surface here and then project the area of the V-tail down to that surface, and that surface is right here, and here is the sketch. So this is simply just a projection of the plan form down, and then I made this a actual SolidWorks surface, and SolidWorks will tell you what the area of that surface is. And there's a little bit of back and forth you have to do with the span and the shape of the plan form until you arrive at the exact plan form you need for your given V-tail angle to get the right amount of area that you are looking for. So once that was achieved, then basically what I did was started putting in stations for the airfoils. So made a bunch of planes at the various sections you can see here. These planes are in my original or master plan form sketch, which is here. This guy here you can see. So we have our master plan form and our airfoil stations, and then those planes I showed you before are going to be used at the stations to insert the airfoils I should say. XFLR was used to create the airfoil data and manipulate the data for each station. Basically you have to use XFLR to change the thickness of the trailing edge, because if you just used one airfoil, right, your master airfoil, and then just kept scaling that down, your trailing edge thickness is going to run into virtually nothing at the tip, and you can't machine a part like that. So XFLR allows you to basically adjust the trailing edge thickness per the chord of each airfoil station to maintain a constant trailing edge thickness. And kind of some manual work goes into that too, or manual math with the scaling. Okay, so basically we have created the plan form and the planes for the airfoils, and the next thing you need to do is basically drop in the airfoils. Now there's some work that has to be done on the trailing and leading edges to create guide curves for the master loft. So here's the trailing edge surface. The edge of this surface is used as a guide rail for my master loft here, and I basically, once I did the loft, I deleted this surface Now I can show you. This is the master loft right here. This basically creates the whole V-tail. So if I go in to edit this feature, it will show you these are the profiles, so these are the airfoils at each station, and these are the guides right here that I use to help this loft along. If you just pick the airfoils, it would sort of pick the path of least resistance and leave you with wavy leading and trailing edges. So we have a guide curve on the leading edge, which again is created by using the edge of a surface. Here's the surface right here. And the trailing edge, again, same thing. It's the edge of this surface here. And then this is a straight line. This is the hinge line, and that's also used as a guide rail. So I have, let's see, 1, 2, 3, and I think I actually have multiple. Yeah, I have 2 guide rails here, so top and bottom. And these surfaces and guide rails are kind of a combination of various sketches, both planar 2D sketches and 3D sketches. So we'll just close this guy out here. Okay, so that loft basically gives you the basic part, and after that you have to do some work. For example, we have to create this channel for the hinge line, and that is also a loft. I believe it is this guy here, so we can edit this loft and I'll show you how this loft was made. So this is the hinge line loft, which is a cut loft, not a sort of an extruding loft. And I have a 3D sketch, again, based off the hinge line for a guide rail, and then we have 2 sketches, one at the root and another one way out here at the tip for the profile. So that creates the hinge line. And really, you have to be familiar with some manufacturing processes to get the right gap between the bottom surface and this surface here. So this gap was given to me by GCM because they knew what it should be. I really didn't know. So they've helped me out with a few things, definitely. This is definitely a collaborative effort. So after I did the hinge line there, I moved on to some other items like doing the joiner. So this is the main joiner, and then we have alignment pins here. These are very easy to do. You're just extruding basically round shapes. Let's see here. Show you, here's a sketch to get these locations. Have 6mm main joiner, 4mm alignment pins. One of these pins might disappear. We might just go with one alignment pin. These are going to be used to make the 3D model of the mold, so that's why these are sticking out like this. The part's not necessarily going to have a part sticking out here. There's going to be a tube sunk in here, and the actual carbon joiner will be on the fuselage, not in the V-tail. And then we have some work here. This is the control horn. Again, this may change. Okay, so that basically completes one V-tail. So this is the left side. This is the top surface here. And in order to make the other side, it's pretty simple. You just mirror it. So I can show you real quick what that would look like. So we can actually just mirror this right now. I'll just kind of show you what it's like. We're going to select the mirror plane or face. So we'll select this guy here. And then we're going to select bodies, this one, and we're going to unselect merge solids and just hit OK. If you had merged solids, it would create a single solid part. And now we have two solid bodies here. And we're going to delete our original body. So let's clear the selection, and we'll select this guy here. And there we go. Now we have a mirrored part, which would be the right side V-tail. Now, if you were to have the same joiner location, this would be perfect. You could just use this as is, but we actually have to move this because we're going to have offset joiners. So I would, I already have done the other part, but I would just delete this extrusion and then create another one where the other joiner needs to be. Oh, I've already done this, so I'll just delete this stuff here. Sorry guys, this might be an extremely boring video for some people, but other people might find this kind of fascinating because it's kind of, you know, behind the scenes of what it takes to create a part like this. So, yeah, that's basically how you get the V-tails. I would say I have well in excess of 15 hours of work into just this part, because this is probably the 5th or 6th iteration of the V-tail that I've made. You know, I have a background in 3D design work with mechanical structures, but the surface modeling and lofting that it takes to do wings and tail components, I'm not so strong in, so there is some learning for me involved, so that, you know, I make mistakes and have to fix them. So it takes a long time, but even if I was an expert at SolidWorks, it would still take quite a long time. So yeah, that's the V-tail done, and obviously you would use this model to create molds. So you would create other 3D models using this molds, using a combined feature or a cavity feature. There's a few different ways to do it in SolidWorks. So obviously you need a way to mount the V-tail to the fuselage, and what we decided to do was to make a plug-in unit that's going to attach to the existing boom that we have, so we don't have to make an all-new mold for the entire tail boom. Basically what we'll do is we'll put the molded booms in a jig and cut off a portion of the back, and then this guy here will plug in, and we'll use another jig to glue it into the boom and make sure all the alignment is spot on. So this guy here was, for me, it was actually harder to make than the actual V-tail itself. So I started out with the original file for the X-tail boom. So let me see if I think still have that here. If I roll back this file, let's see. Maybe too much. Okay. Here are portions of the original file for the X-tail boom, and I think I have this guy opened here. So here it is. Now, GCM, they use a completely different program than I do to create their 3D models. They're doing entirely surface modeling, and SolidWorks is more solid modeling, or I should say I work in solid modeling. So this is a different file type that I had to import into SolidWorks. So there's quite a bit of work that has to be done to get usable surfaces and cross sections out of a file like this. So that's what I've done in this file here. Anyway, so I got a cross section right here, and was able to use that as a basis for the solid part, and I have the center line of the entire boom to help me with these lofts, so we make sure that the incidence angle on the V-tails is correct. So like I said, I've done that. And we'll go down here. So I created a basic loft here, and then imported our finished details. So again, like I said, we made that mirrored part, so I've sort of assembled everything here, and this has given me something to start working with, right? So that's what our details are going to look like, and let's roll this a little further ahead. So we've started in on doing some work trying to get this part carved out. If you can imagine, this would be like a piece of wood and you're trying to whittle away at the part or add material to the part to get it to what you think it should look like. In your head, we have some fillets that we've made here where the V-tails intersect this loft to help with transitions. Ideally, I would like bigger transitions, but I couldn't really get them any bigger in Solidworks, so that's the best I could come up with. Then if we roll this down a little further, we have the part taking shape. What I've done here is basically cut half the part away because I found it's easier just to work on half of the component and mirror it when it's all done. So that's what we've done. Actually, let me show you. Go up here. So if you look right here, a lot of V-tails have a cone that covers where the control horns would attach to the push rods. To me, on a model like this, the F5J model, which is not flying at high speeds at all, the drag created, or the drag that's reduced by having a cone like that, is not worth the hassle of actually assembling the V-tails and making it easy to assemble. So I have kind of stolen a design from the Infinity, which has a cutout like this, so the push rods are exposed. So as you can see here, I've extruded cut some sections away where the linkage is going to hook up. So we have basically kind of like a rib back here, and the push rod will hang out here, and you'll see the control horn exposed. Let's roll forward a little bit more, and you should see the V-tails disappear. This is a extrusion here to allow for the movement of the moving surfaces. You don't want the moving surfaces just butted up directly against a surface. You need a bit of a gap there. That's what we have. And then I'll just move ahead to the kind of the finished product here. There we go. This is basically the finished product. It's been mirrored, so you can see the whole thing is accurate. Now, the way that I'm going to get the holes in here for the joiners, the alignment pins, is basically by assembling the V-tails onto this, and we'll use the combine feature to allow us to make these holes for us. So let me see if I have that open. Right, here's the assembly I made. So we have our original V-tail, which is the left side here, and the mirrored V-tail here, which is the right side. And they have been attached to our V-tail mount. You can see the control horns hanging out here. These are going to get ball links, so they're going to get little MP Jet ball links. So there'll be a brass ball here on the finished product. So what you would do with this assembly is save it as a part. So we can do that right now. I'll show you guys how this works. We'll just select part, and I'll just give this I've already done this, so I'll just give this a assembly 6 name. Doesn't mean anything. Go open that part. So again, once this file that we're opening is no longer a assembly, it's actually a part. Sure, whatever. Recognize features. Fine. Okay. So now we can use a feature called combine to help us get those holes in our V mount, or the middle section. So we'll go to combine, and it's already on subtract, but you could also select add if you wanted to do other things. So we're on subtract. We're going to select the V-tail mount as the main body. And bodies to combine, or since we've selected subtract, bodies to subtract. We'll select these guys here and hit OK. Let it do its thing. I don't have the fastest computer in the world, so it's kind of slow. Alright, there we go. So as you can see, if we go back to if we go back to our original V mount, there's no holes in this guy. So we've used that combine feature to create the holes for us. Makes our lives a little bit easier. Okay, so from here, this is basically a finished part. So we have the V-tail mount, and we have the actual V-tail itself, which I showed you earlier. Apologies if you can hear my gardener in the background. So we have to be able to make these parts somehow, right? So if we were going to go straight into machining molds, maybe out of aluminum, we'd have to use these files to create other 3D files to make molds. And again, we'd sort of use the same combine feature to help us make those molds. And there's also a mold tool in SolidWorks. We could use that. So there's a few different things we could do. So what I'm going to do to help create prototype parts is to actually make a mold of the V-tail mount. And the V-tail itself is kind of a known quantity, so we might go straight to aluminum molds with that. I'm not sure yet. We might mill some plastic molds too. We're not going to do any 3D printing work with that, but we might make prototype parts. But for this mount, I'm actually going to make some composite molds, epoxy molds, and try to make a part for test fitting purposes. So what I've done basically is I have this part here, and I have made some what would you call these, splitter boards, splitter planes, to help create a mold. So I'm 3D printing all of these parts, so these braces, the splitter planes, and like I showed you at the beginning of this video, the actual V-tail mount itself. And I'm going to use these parts to help create a epoxy mold, and I'll show you that in a future video. But again, I'm using SolidWorks to make all these parts, and I've used the combine feature to create some of these parts. So alright, well, I mean, I think that's just a very quick look at what it takes to create some of these parts. This is just sort of a small part of a complete model. You know, we're basically just working with two tail surfaces and this V-tail mount. And I probably have 30 hours of work into this. And you can imagine what it would take to create the entire model. And that doesn't even include any of the other work that goes in with aerodynamic analysis, running simulations and programs on that end, and it doesn't include making the files for the molds. So it's a ton of work, guys. So I know a lot of these airplanes are super expensive, but I hope you get an idea of the amount of work that goes into creating something like a F5J model through this video. All right, that's pretty much it. This was a little different video. Hope you guys enjoyed it. I'm going to make a few more videos on the V-tail for the Vertigo. We're going to make this mold for the V-tail mount, and I'll show you guys some of the behind the scenes at milling the molds for the V-tails themselves, whether they're aluminum or plastic or some other material. We don't know yet. Hope you guys enjoyed this video, and I will see you in the next one.